Okay, so for today I will discuss on problem solving for problem involved with conservation of momentum. Okay, so first let us look into linear momentum. Okay, collision in one dimension. Okay, so one dimension, that means you will either have x or y component only. Okay, so for this part, okay, we have example 3. Okay, so over here you have figure 3.14. Okay, you have object A. Okay, mass given 200 gram. Okay, collides head on with object B, mass given 100 gram. Okay, and after the collision, B moves at a speed of 2 meter to the left. Okay, they wanted to determine the velocity of A after the collision. Okay, so initially A and moving toward each other, so that means you will have a head-on collision lah. Okay. Okay, now for the solution, the information given over here. Okay, mass of object A. Okay, mass of object B. So given in gram, make sure you convert into kg lah. Okay, it should be in kg. And then the initial velocity of object A. Okay, you have negative sign over here because it is moving toward the left. Okay, and then initial velocity B. Okay, so positive direction. Okay, positive 3 meter per second. And we know after the collision B moves 2 meter per second to the left, so that means moving toward left. Okay, so make sure you include the sign convention lah. Okay, so according to the conservation principle, okay, total initial momentum will be equivalent to the total final momentum after the collision. So initial momentum, okay, product of mass and velocity, okay, ma ua plus with mb ub, okay, total momentum of A and total momentum of B. Okay, after collision it will become ma va, okay, final velocity. Okay, now we already have the information. If we replace in all the information, okay, then what we do is that we solve it to determine the final velocity lah. Okay, unknown over here is that velocity of object A. Okay, so for this one we will end up with negative 3.5 meter per second. Okay, so that means the object is moving to the left. Okay, next let us look into collision in 2 dimension. Okay, so this one we have example 4. Okay, figure given. Okay, this one you have a tennis ball, mass m1, okay, moving with the initial velocity u1, collides with the soccer ball, okay, mass given m2, which is initially at rest. Okay, after the collision, the tennis ball deflected 50 degrees, okay, from initial direction with velocity v1 as shown in the figure. Okay, suppose that m1 mass given and m2 given. Okay, initial velocity u1 is given and the value of v1 is given. Okay, so they wanted to calculate the magnitude and direction of the soccer ball after the collision. Okay, so this one for solution, okay, like the previous one, okay, derive all the information that we have. Okay, mass 1, mass 2, initial velocity. Okay, so this one we have to solve it part by part lah, or by component. Okay, so from the conservation principle, total initial will be equivalent to total final momentum. Okay, so this one we solve it for x component first. Okay, so x component you have to resolve lah. Okay, so initially object is moving to the right. Okay, so you don't have any angle, and then the football at rest. Okay, so the total momentum will be 0. Okay, after collision you have a angle. Okay, so after collision you have angle. Okay, so mass given. Okay, so this one unknown lah. Okay, x component unknown. So what you can do, you can replace in the value v1. Okay, already given. Angle also we have. Okay, so by solving, we will end up with the value of the x component. Okay, so just leave it as x component lah. Okay, value of the x component. Okay, next what we can do is that we need to solve for y component. Okay, so using the same conservation of momentum, we do it for y component. Okay, initially y component is 0 over here. Okay, after collision, okay, object, that means the tennis ball moving downward, so that means you will have a negative value over here, and then for the y component is unknown lah. Okay, we are going to determine, so which we end up with 0.851. Okay, now we already have the x and y component. Okay, so once you have the x and y component, what you need to do is that you need to determine the magnitude. Okay, do it like how you do it in chapter 1. Okay, find the value of the magnitude, which will end up with 4.91. Okay, and then since we have x and y component, we can determine the direction. Okay, y component over x component, which we end up with 9.97. Okay, so the angle will be located 9.97 degrees from the positive x-axis lah. Okay, or above the positive x-axis. Okay, that's all for this part. Okay, have a nice day.